Hi, students and friends. This is your host and teacher, Sayyid Ayazuddin Haider. You're watching Learn and Teach by Sir Ayaz. So, I'm continuing my O level past papers session, and this time I've selected CAIE Chemistry 5070, and we have October November 2024. Variant is 41. You know it's paper 4, alternative to practical. It's of 1 hour. You have to answer all the questions. You can use calculator. The total mark for this paper is 40. Important point, you are provided with the notes for use in qualitative analysis like this. It includes test for anions, test for aqueous cations, test for gases, flame test for metal ions. So let's start the paper. Here's question number 1. A teacher investigates the electrolysis of molten lead to bromide. Lead to bromide is a solid at room temperature. Figure 1.1 shows the apparatus that teacher uses. Here's the apparatus. Figure 1.1, we have power supply, we have lamp, we have electrodes L and M, we have crucible containing molten lead to bromide. A. Name the pieces of apparatus labeled L and M. The name for these is L and M is that they are electrodes. Suggest the material from which L and M are made. So you can write platinum, or carbon, or you can even write graphite. Graphite is the allotrope of carbon, which is used here as electrode, which can be used. B. Describe the appearance of the products at L and at M. So first of all, you should know what you are getting at L and M. L is cathode. This one is cathode. And M is anode. So at L, you will be getting lead. And at M, you will be getting bromine. Now what they are asking? They are asking about the appearance of product at L. So at L, you will get silvery beads or solid. Silvery, you can even write black, gray, beads or solids. Beads or solids. Solid. You can even write liquid because it's molten, so you will get the molten form of the lead. What about the appearance of product at M? At M, we are getting bromine. So we know at high temperature it exists as brown gas, red-brown gas. So you write red-brown gas. Moving to next part, which is part C. The teacher stops heating and allows the lead to bromide to cool. Explain why the lamp goes out. So the lamp is lit up due to the movement of free ions in this molten. We are having free or mobile ions here. Due to this, we are having lamp lighting up. So current is flowing. Current is flowing in the wires, and you have the movement of ions or charges in the molten, which is electrolyte here. So if you stop heating, what will happen? This will solidifies molten lead to bromide, which means there won't be any current to flow. So we'll write molten lead to bromide solidifies. Molten lead to bromide solidifies. Current cannot flow in the solid. Moving to next question, which is question number 2. A student titrates 4 samples of 0.8 mole per dm cube aqueous sodium hydroxide NaOH aqueous with aqueous ethane dioic acid. In titration 1, the student rinses and fills a burette with aqueous ethane dioic acid, uses a volumetric pipette to add 25 centimeter cube of NaOH aqueous to a conical flask, adds thermophylline indicator to the conical flask, places the conical flask on a white tile, adds aqueous ethane dioic acid from the burette while swirling the flask, adding drop by drop near the end point until the solution just changes color. The student repeats the titration 3 more times. A. Figure 2.1 shows the burette readings for the 2 of the titrations. We have titration 1 and titration 2. It's figure 2.1. Record the burette readings in table 2.1. Complete table 2.1. We are having table 2.1. We need to complete for experiment 1 and titration 1 and titration 2. These are titration numbers. Titration 1 and 2, as well as we need to, later on they will definitely ask us to complete these values also. Yes, 3 and 4 also. So 1 and 2. So for 1, initial reading will be 0.2. Here you can see it's 0.2 and final reading must be 21.1. What about titration 2? It's 21.123. 21.3. Final reading must be 41.1234. 1, 2, 3, 4, 5, 6, 7, 8. 41.8. Now I'm going to write it down in the table. So final burette reading for titration number 1, 21.1. Initial burette reading 0.2. For titration number 2, final burette reading 41.8. And initial burette reading 21.3. For titration number 1, volume of ethane dioic acid added per centimeter cube, it's 20.9. For titration number 2, it's 20.5. Now for titration number 3, initial reading must be 0, because if you subtract 20.0 from 20.1, you will get 20.1. What about titration 4? 40.4 minus 20.5. So it must be 19.9. Yes. B. Tick to the 2 best titration results in table 2.1. 2 best titration results. They must be in a difference, the least difference, like 0.2. And we are having titration 3 and titration 4. 20.1 and 19.9. C. Use the ticked titration results in table 2.1 to calculate the average volume of aqueous ethane dioic acid needed to neutralize 25 centimeter cube of the aqueous sodium hydroxide. So we have 20.1 plus 19.9. If you will add up these values, what you will get? you will get 40 and divide 40 by 2, get 20 centimeter cube. This will be the answer. Part D. Calculate the number of moles of NaOH in 25 centimeter cube of 0.8 mole per dm cube NaOH. So 0.8 mole per dm cube means it must be in 1000. So you'll write 1000 centimeter cube contains 0.8 moles. Therefore, 25 centimeter cube contains X moles. Do the cross, you will get X is equal to 25 multiplied by 0.8 divided by 1000. Multiplied by 0.8 divided by 1000. 0.02 moles. So I will write 0.02. E. 1 mole of ethane dioic acid is neutralized by 2 moles of sodium hydroxide. Use your answers to C and D. Calculate the concentration in mole per dm cube of ethane dioic acid. Give your answers to 3 significant figures. So we have ethane dioic acid and sodium hydroxide. So we have this information. They are saying 1 mole neutralized by 2 moles sodium hydroxide. Therefore, X moles neutralized by 0.02 moles. So X is equal to 0.02 divided by 2. You get 0.01 moles. So these are the moles present in 20 centimeter cube. We have the volume of ethane dioic acid. It's here. So it's in 20 centimeter cube. So I will write 20 centimeter cube contains 0.01 moles. Therefore, 1000 centimeter cube contains X moles. In this way, we'll get mole per dm cube. The answer must be mole per dm cube. 0.01 multiplied by 1000 divided by 20. 0.01 multiplied by 1000 divided by 20. You'll be getting 0.5 moles per dm cube. This will be the strength of ethane dioic acid. Moving to next part, which is part F. The formula of ethane dioic acid is C2H2O4 NH2O. 100 centimeter cube of the aqueous ethane dioic acid contains 6.3 gram of C2H2O4 NH2. Use your answer from E to calculate the relative formula mass MR of C2H2O4 and H2O. So if you look here, they are saying 100. The mass of ethane dioic acid so we write 100 centimeter cube contains 6.3 grams. Therefore, 1000 centimeter cube contains X grams. So the X becomes 6.3 multiplied by 1000 and divided by 100. So you will get 63 grams. 63 grams. So these 63 grams are in 0.5 moles. So now you can calculate the relative formula mass. Relative formula mass. We will write 0.5 moles have RF of 63 grams. Therefore, 1 mole have RF of X. So we'll write 6X is equal to 63 divided by 0.5. So what you will be getting? 63 divided by 0.5, 126. 126 will be the MR, or relative formula mass of C2H2O2 dot NH2O. Number 2, use your answer from F1 to deduce the value of N in C2H2O4 dot NH2O. Give your answer to the nearest whole number. Now we need to find the value of N. AR of hydrogen, carbon, and oxygen is provided. So what I'm going to do, I'm going to put these AR in this formula. So we have C2H2O4 dot NH2O. C2 multiplied by 12 plus, we have 2 atoms of hydrogen, so 2 multiplied by 1 plus 4 atoms of oxygen, 4 multiplied by 16 plus, the MR of H2O. If you want, you can calculate it here. H2O, we have 2 atoms of hydrogen, so 2 multiplied by 1 is 2 plus 16 for oxygen, it will become 18. So I will write 18 N here is equal to MR. I have calculated, it's 126. Now this whole become 24 plus 2 plus 64 plus 18X is equal to 126. Plus 2 plus 64, 90. 90 plus 18X is equal to 126, or 18X is equal to 126 minus 90. Or you will get X is equal to 126 minus 90 becomes 36. 36 divided by 18. So X will be 2. Multiplied, the value of N is 2. We got the value of N, it's 2 here. This will be the final value of N. G, state why the conical flask is placed on a white tile before aqueous ethane dioic acid is added from the burette. So we are adding hamophthalene. It changes color. Here, if you look at this, the indicator is added here. Indicator, due to the presence of indicator, we are having change of color. So you can observe the color change easily here. So we write to observe color change easily. To observe color change easily. H, state why a measuring cylinder is not used to measure 25 centimeter cube of NaOH aqueous in this experiment. So we need a glassware having high precision or accuracy. Measuring cylinder is not accurate. So you can write measuring cylinder is not accurate. Moving to next question, which is question number 3. A student investigates solid Y and solution Z. A. Solid Y is a white powder. The test the student does on Y are shown in table 3.1. Some of the observations for these tests are also shown. Here is table 3.1. Test on solid Y. In one, they have added excess dilute acid to Y in a boiling tube. The gas produced is tested using lime water. Observations, colorless solution found, lime water becomes milky. It must be due to carbonate ion. So I'm going to write carbonate ion. Must be due to carbonate ion. Number 2, add dilute nitric acid to some of the solution from test 1, then add aqueous barium nitrate, getting white precipitate. So if you look at that list, barium nitrate is used to test the presence of the sulfate ion. We are having sulfate ion, use barium nitrate. So it must be presence of sulfate ion here. Okay. Number 3, add aqueous sodium hydroxide drop by drop to some of the solution from test 1 until a change is seen. Then add excess aqueous sodium hydroxide. White precipitate, which is soluble in excess, giving a colorless solution. So with sodium hydroxide, we used to check the presence of cations. With sodium hydroxide, we can either have Al3 plus because soluble in sodium hydroxide, as well as Zn plus 2 or 2 plus. It's also soluble in excess. So you have both Al plus 3 or Zn plus 2 here. Number 4, add aqueous ammonia drop by drop to some of the solution from test 1 until a change is seen. Then add excess aqueous ammonia. White precipitate, which is soluble in excess, giving a colorless solution. Now, with aqueous ammonia, Zn2 plus, it is soluble in excess, giving a colorless solution. So here, it's confirming like presence of this Zn plus 2 ion. Number 1, describe how the gas is passed through lime water in test 1. You may draw a label diagram to help answer the question. Now, what we need to do, we need to bubble the gas through lime water using delivery tube. So you write gas bubbled through lime water using delivery tube. For the diagram, you can draw test tubes here. Can have test tubes like this. Like this, and you are having cork here. This one is lime water. This is delivery tube. This must be contain CO3 ion of the salt containing this CO3 2 plus ion, 2 minus ion. Number 2, describe 2 other observations the student makes in test 1. In test 1, the reaction is between carbonate ion and acid. If you look at this, dilute acid. So the other observations, so it must be bubbling due to the production of carbon dioxide gas. So you write bubbling or effervescence. Bubbling or effervescence. Second must be solid disappears or dissolves. Solid disappears or dissolves. Part 3, identify the gas produced in test 1. It's definitely carbon dioxide. I've already mentioned. It's turning lime water milky. So it must be carbon dioxide gas. The gas, carbon dioxide. If you look at the test for gas, say it's carbonate ion. On reaction with acid, it produces effervescence and carbon dioxide produce. The test for the carbon dioxide gas is here. It's turning lime water milky. So it must be carbon dioxide. Number 4, Y contains 1 anion. Use the observations from test 1 to identify this anion. It must be the carbonate ion. I've already mentioned here. It's carbonate ion, which is responsible for the production of this carbon dioxide gas when it's reacted with acid. So you write carbonate. Carbonate or CO3 minus 2. Number 5, use the observation from test 2 to identify the dilute acid used in test 1. So in the test 1, we are getting white precipitate with barium nitrate. So with barium nitrate, the barium must be reacting with the sulfate ion. To form this BaSO4 or barium sulfate. And that sulfate ion must be coming from sulfuric acid. Sulfuric acid is H2SO4. So it must be sulfuric acid. Number 6, identify the cation in Y using the observations from test 3 and 4. Already explained it to you. It must be Zm2 plus ion. After looking at the test and results in 3 and 4. So you'll write Zn plus 2 or zinc. Part B, solution Z is colorless. Number 1, the student thinks that Z contains Cu2 plus ions. State why the student is not correct. The reason is that solution is colorless. You can even state the color of Cu plus 2 ion, which is blue. Solution is not blue, or solution is colorless. Number 2, solution Z contains K plus ions. Describe how to do a flame test on solution Z to confirm the identity of this cation. It's of 3 marks. So you have to write, use a wire or sprint to dip in solution Z? In the first step, use a wire or splint to dip in solution Z. Place or bring it to blue or non-luminous flame. Observe color of flame produced. Observe color of flame produced. Or state the color of K plus. What will be the color of K plus? It's K plus, it must be lilac or lilac flame. Part 3. Solution Z contains ions of group 7 element. Describe a test and the possible results to identify which group 7 ion is present in Z. So these are the halide ions in our syllabus. We have chloride, bromide, iodide. These are the 3 halide ions. So all are having same test. That is, you have to acidify with dilute nitric acid, then add aqueous silver nitrate. For chloride, you will get white PPT, bromide, you will get cream PPT, and for iodide, you will get yellow PPT. So in this, you have to use qualitative analysis note. So I will write add dilute nitric acid followed by aqueous silver nitrate. Observe color for the presence of halide ions. It's of 3 marks. So you have to mention the color. We have as white, cream, or yellow precipitates. Moving to last question. Just question 4 here. Argentine is an alloy containing only zinc, nickel, and copper. Zinc and nickel both react with dilute hydrochloric acid. Copper does not react with dilute hydrochloric acid. Plan investigation to find the percentage by mass of copper in a powdered sample of Argentine. Your plan must include the use of common laboratory apparatus, Argentine, and dilute hydrochloric acid. No other chemicals should be used. Your plan must include the apparatus needed, the method to use, and the measurements to take. Procedures to ensure that the percentage determined is as accurate as possible. How the measurements are used to determine the percentage by mass of copper in the sample. You may draw a diagram to help answer the question. If you look at the total mark for this question, it's of 6 marks, and they gave space also. It's for the diagram. So how the marks are divided? You have 1 mark from each section. And what are these sections? We have apparatus, we have method and measurement, we have accuracy. You want to get the accurate result. Huh? We have calculation also. 4 marks are done here. 1 mark from each. You can gain 2 marks from any of these. So I can straight away draw 2 apparatus in order to gain 2 marks. This will make my life easy. So for the apparatus, suitable named container in this reaction, like you have beaker, you can use beaker in this reaction. So I'm going to draw the beaker. This is beaker. I will write beaker here. Weighing balance. It must be like that. It's weighing balance or beam balance. Measuring cylinder. Filter funnel. You can even have stirrer for this reaction. Stirrers like that. A glass rod. Stirrer or glass rod. Stirrer or glass rod. You can draw any 2 of these to gain 2 marks. We got 2 marks here. Now we are left with 4 marks. For the method and measurement, method and measurement. Weigh the mass of alloy or Argentine. Weigh the mass of alloy. Name the alloy, which is Argentine here. If you want, add hydrochloric acid. Add hydrochloric acid. Filter. Weigh copper. Now I got 2 marks from here. 4 marks are left. For accuracy, use acid in excess. Use acid in excess. So that both of these will react completely. So you can write until, or for this one, or until bubbling stops. Bubbling, you will definitely get bubbles. When acid reacts with metal, they will produce hydrogen gas in the form of bubbles. Bubbling stops. Wash and dry. Wash and dry copper. Repeat and take average. In order to get accurate result, you need to repeat and take average. Now I will write 2 points from this accuracy. Now I got 6 marks here. But the point is that you have to write one statement for calculation also. It's very important. So you can write anyone from accuracy or anyone from method and measurement. So for the calculation, which is very important, percent copper. How are you going to find the percentage? Mass of copper multiply by 100 divided by mass of alloy. In this way, you can gain full marks for this question. Thanks for watching. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.